Okay, so second example here. We've got 3 functions this time instead of just 2, so that means there'll be 3 pieces. Now, when you're looking at these functions, that means that we have everything that's going to be less than -1, so that'll be headed towards negative infinity. We have this piece in the middle that will have a starting and an ending point, and we have this piece at the end that will be bigger than 3, so we're going to be heading off to positive infinity as far as the x's are concerned. So I'm going to take my first function here, that's just the constant function of 5. I'm going to put that over my first table. Now again, we do need to look at our rules for our piecewise function, so we're looking at this first rule here, and it says that when x is less than -1. So I want my first value to be -1. Even though it's less than, even though we're not including that point, we do want to have an open circle at -1. So then all numbers smaller than -1, -2, -3, -4, etc. And the best thing about constant functions is that whatever your value is, that's going to be the answer every time. So it's just going to be 5, 5, 5, 5. Constant functions are easy to graph, and they're one of my favorites. And so we have an open circle because we know that from our rule here, where x is less than -1, it's not including -1, and that's going to extend for the rest of the graph towards negative infinity on the x values. Our second piece here, we have a linear function of -3x plus 4. So I'm going to write that over my second table, -3x plus 4. And now this time, the rules say that I need to start at -1, and I'm going to end at 3. I can pick any other values in between, so I'm going to go with 0 and 1. You could have picked 2 as well, doesn't matter. You could even make another spot in your column, put 5 values, because you're only going to have 5 points. Now, when I plug this in, -1 times -3 gives me +3, plus 4 is 7. Anything times 0 is 0, plus 4 is 4. -3 plus 4 is going to give me 1, and -9 plus 4 will give me -5. Yeah? No, that's too big. -9, oh, that does. And so when I plot these points, we have closed circle and closed circle because we have less than or equal to and less than or equal to. That line underneath those inequality signs tell us we're going to include that point, so we're going to have closed circles at both of those. And then my last piece of my function here is going to be 2x minus 6, and my rule is if x is greater than 3. So I'm going to put 2x minus 6 over my third table. Oops. 2x minus 6 over that third table. And again, messing that up. So my rule says if x is greater than 3. So I'm starting with 3 on my table. And then I want numbers bigger than 3. So 4, 5, and 6 all work. You could pick a different number if you want. When I plug these in, I have 3 times 2 is 6, minus 6 is 0. 4 times 2 is 8, minus 6 is 2. 5 times 2 is 10, minus 6 is 4. And 6 times 2 is 12, minus 6 is 6. So when I graph this one, we did have an open circle here because x is greater than 3. We're not including 3. There's no line underneath that. So we've got a open circle, and then that line is going to extend on the graph till positive infinity on the x-axis. So when I graph these 3 pieces, none of them are going to overlap. We're just going to have our 3 pieces that stop with the open circle and then finish up with that closed circle. So my first piece here at -1, 5, I'll have an open circle. And then I'm going to graph -2, 5. That's that constant function. It's pretty nice and easy. It's just going to go forever in that straight line all the way to the left. Next, I'm going to graph my middle piece. My middle piece has a starting and an ending point. Because if we had an arrow on either end, it wouldn't pass the vertical line test. All piecewise functions are going to pass the vertical line test to know that it is a function. So this one's at -1, 7. That's a closed circle. And then 3, -5. I'm just going to graph the starting and ending point. I know they have to connect. I know it's linear, so I don't need to worry too much about those middle points. If you want to plot them, feel free. And then my last piece here is an open circle at 3, 0. So 3, 0, open circle. And my graph is going to extend 4, 2, 5, 4, and 6, 6. So that'll look like this. Now, again, if we look at that vertical line test, we'll see it's going to pass the vertical line test, even though this is open here, closed here. There's no double point. If these were both closed, then it would not pass the vertical line test. So we always want to check for that one is open and one is closed when we have two with the same x value. And the last thing we need to do here is look at domain and range. So we'll take a look at that. Domain, we've got every x value from negative infinity to infinity is included. If we had two open circles here, then we would have to approach 3 from both sides, and we'd have a union. But we don't have that in this case, so we don't need that. Our range here, our lowest value is -5, and our highest value is infinity. So we're going to take that all the way to infinity.